Hi, my name is Bill Reddington. I'm a lecturer in engineering and mathematics at the Dublin Institute of Technology. Today I want to talk about matrices. Now, matrices are very important in engineering. They allow us to solve linear simultaneous equations, and that means we can calculate things like current flowing in a circuit or forces acting on a component within an assembly, etc. So let's have a look at two linear simultaneous equations. If we take the coefficients and if we arrange them in the following order, maintaining the same relative position in this arrangement as in the original equations, we have what we call a matrix or an array. And each of the coefficients within this matrix are referred to as elements. Now we can have any number of rows or any number of columns, and generally we refer to the number of rows as m and the number of columns as n. Now we also say that the matrix is of the order m by n. So in this case our matrix is 2 by 2. There's 2 rows and 2 columns. Now if the number of rows and the number of columns are the same as they are in this case, we say that the matrix is a square matrix. Now here we have another two simultaneous equations, but this time we have 3 unknowns, x, y and z. And once again, if we take the coefficients and if we arrange them, maintaining the same relative position as in the original equations, this time we have 2 rows, 3 columns, so we refer to the matrix as being of the order 2 by 3. Now it is possible to have a single matrix, or a single row and a single column. And if we have a single row, we refer to the matrix as a row matrix. And if we have a single column, we refer to the matrix as a column matrix. Now it's possible to add, subtract and multiply matrices. And before we do that, we need to understand some basic rules that we must apply. So let's have a look first of all at adding two matrices. When we add two matrices, we make sure that we add corresponding elements from each matrix, and this gives us one single matrix. So for example, let's say we have two matrices M1 and M2, and if we want to add these, M1 plus M2, we add the corresponding elements. So 2 and minus 3 is minus 1, minus 1 and 0 is minus 1, minus 7 and 7 is 0, and 4 and 4 is 8. Now also, it's worth noting that usually we refer to matrices with a capital letter, as in this case here. Now, subtracting two matrices is similar to addition. Again, this time we subtract corresponding elements of each matrix to give us a single matrix. So let's look at another example. Here we have two matrices M1 and M2. And if we subtract M2 from M1, we say 2 minus minus 3, which is the same as 2 plus 3, which is 5. Minus 1 minus 0 is minus 1. Minus 7 is minus 14. And 4 minus minus 4 is the same as 4 plus 4, which is 8. Now it's also possible to multiply a matrix by a constant or a scalar. For example, let's say we want to multiply a matrix M by 2. Well, what we do in this case is we multiply each of the elements by 2. So 2 times 1 is 2, 2 times 3 is 6, 2 times minus 4 is minus 8, and 2 times 6 is 12. Now we can combine the addition, subtraction and multiplication by a scalar into one example as we have here. So here we have 3 matrices A, B and C. They're all 2 by 2 matrices, and we want to calculate 2A minus 2B plus C. So first we multiply each of the elements of A by 2. So this gives us 2 3 is 6, 2 2s are 4, 2 minus 1s are minus 2, and 2 times 4 is 8. And then we multiply all the elements of B by 2, and this gives us the element, or the matrix 4, minus 2, 10 and 6. And now we take 2B from 2A and we add C. So this involves adding and subtracting the individual or the corresponding elements. So 6 minus 4 is 2, and 2 and 3 is 5. 4 minus minus 2 is 6, and 6 and 4 is 10. Minus 2 minus 10 is minus 12, and minus 12 and minus 1 is minus 13. 8 minus 6 is 2, and 2 and minus 2 is 0. So you could have a look at a question now. So here we have 3 matrices P, Q and R, and we're asked to calculate 3P minus 2Q plus R. So stop the video now and have a go at that question. And the answer to the question is 2, 14, minus 26 and minus 2.